Alright. So I know I have what looks like a bunch of homework problems for videos of homework problems, and now I'm doing something just limits. But when I studied, or when I learned calculus, and then when I studied calculus later on, just watched videos or whatever, and then when I tutored calculus, I got 3 different syllabi, and so, but I know limits are a main factor, and one of the ones that when I tutored it was applied calculus, so it was more geared toward engineering. So I wanted to kind of make sure that I have some supplemental videos that are just as instructive. So anyway, in the last one we went through, let's see, to begin with we went through limits as x approaches a certain number, where you could just plug it in and you get a certain number. This one, 7/5. And then I did it where you can use factoring algebraically, and you get where it gave us 0 in the beginning, so we factored it out, knocked off the common terms, and gave us 11/4. And this one did the same thing. It was just a little more ugly with the square root, but we found like terms, crossed them out, got a 1, and then this and that, plugged it in again, and then we got 1/26. And then this one I showed you was kind of a basic example. Oh, actually there's 2 examples. This one is, well, what you'll see these, and I'll do some more later, and then you'll get kind of like what happens when you have a lower power on top or here, and then later on what happens when you get a higher power on top. And you can kind of imagine, right, this would be flipped, so it would go to infinity and not 0. So anyway, so I got 1 or 2 more problems I wanted to add on this one. Let's see, did a little more hard, and I don't want to discount, by not giving, I don't really like this color, I don't want to discount by not giving you good problems to have, Let's see. Alright, so we got the limit as x approaches 3, and I got this from ucdavis.edu. So there's some calculus problems. Alright, let's see, x to the 4th minus 81 over 2x squared minus 5x, what is it, minus 3. Alright, so if we plug it in, we get, let's see, just go ahead and do that. 3 to the 4th, that's 81, right? 3 times 3 is 9, and then 9 times 9. So we got 81 minus 81. And, we can have a solution that's 0, but if it's 0 over 0, which I fancy it will be, then we can try to find some other solution. And you get even more hairier problems later on when you use a tool called L'Hopital's rule, and it helps you find the derivative of it and then see where the limit goes. And if that limit exists, and it exists in the original argument or function, even though it was 0 of 0. So it can be kind of fun. Alright, let's see. 2, oops, let's just simplify it. 2, that's 18, right? 3 times 3 is 9, it's 18. Minus 15, and then minus 3. So we get 0 over 0, don't we? 18 minus 18. Alright, so we could do some more factoring, and this is just a little uglier because, or hairier, because it has 4, this one, that one's not, well, that is a, whatever, a coefficient out here. Alright, let's see. We did the x squared minus 9, right? X squared, this is a numerator. X squared minus 9. Oops. X squared minus 9, x squared plus 9. And then for the denominator, let's see. Well, we're probably going to want to get one of these out. So if we were to even factor this one out further, probably the negative, because the negative always seems, see how it's a minus, and all the other ones, if you notice, they were a minus also that we got rid of. Well, not those two, those are different types of problems. Put the minus, that would give us a 0 in the denominator. Let's see. And the minus here, because it gave us a 0. Because if you put it in here, you get a positive number. That's a real number. Well, we didn't have to do it here because it just fitted in. Alright, so let's do... I'm gonna leave this one foiled. Or factored, I mean. Let's see. So x minus 3, this is just the first term right here. X minus 3, x plus 3. And then all that times x squared plus 9. Alright, so that gives us a better example of, maybe what we're trying to look for. I mean, let's see, we can't take a 2 out of everything. I'm just trying to find the denominator now. So we could do an x minus 3, because we know we're going to cancel it out. If we do an x minus 3, well, we could do a 2x, right? We can take we can take it out later, if we can. So 2x squared, that's 2x squared, minus 3, that's what? Plus 1. 1, that's 2, right? Minus 6x plus 1x. That's good. Alright, so I'll just bring this over here. So we got, and I'll put it under here, x minus 3, so we know they'll cross out. And we don't need anything else to cross out, we just got to get that term out of there. And thankfully it works, but then again, it's kind of built like that, these problems. Alright, so we got this. So I'm just going to rewrite the equation, use a different color. Kind of an ugly, but it's almost Halloween here, so here. It's almost Halloween in the now. Alright, so we got x plus 3, x squared plus 9 over 2x plus 1. I can put that in parentheses, it doesn't matter. Alright, and we had, what was our limit as it went to, oops, the limit, did we use that ugly color? No. What did I do, just write a problem? No, I don't think so. Let's see. I limit, okay, as x approaches 3. So I just rewrite that. Limit x approaches 3, and this is the same thing. This is equal to those up there. Alright. Alright, so we got 3 plus 3 times 3 squared, that's 9. 9 plus 9 over 6 plus 1, that's 7. So we get 6 times 18 over 7. And that equals, that was a little longer, that's for sure. But that was kind of fun. Let's see, I can put my little calculator here. Six times 108. I didn't want to solve it yet, really. Over 7, and I don't think it's gonna. Let's see if it gives us a round number. I doubt it. Nah, 15 point. Well, we could just round it if we wanted to. I'll leave it like that. Alright, that's it. 108 over 7, and I'll do some more in the next few videos. Hopefully it helps, just because, like I said, this is how I learn pretty much. And I mean, well, this is how I didn't say that, I suppose, but it's pretty much how I learn, is watching videos, and it's just helpful. I may put commercials in here or something like that, but it takes time to set up the problems. It's not a big deal. And I just want it to be helpful. I don't know, it's kind of fun to make them, and you learn more as you try. And what I've kind of found out, you learn more as you teach or whatever. And what I've kind of found out is that every time you can come up with a new problem, and as much as calculus, or I guess any math, you get challenged, because it's not the same ones you can remember. It's easy to say, well, maybe not easy in here, I don't want to confuse you, but it's easy to take, let's see, it's easy to do maybe simple problems, like the first one, I suppose. And you could do that all day, no matter what. You could just type it in. All you have to do is remember that if it's the limit, you could just try to plug it in. You know, but if you get a problem that's like a lot more harder with like 10 polynomials or whatever, and same thing with the denominator or whatever, you might get confused. So there's, you know, as much as you know it, sometimes there's, you know, it's kind of like the next problem around the corner that will confuse you. So it's kind of nice doing these two in a way, because it still stretches my brain. Alright, so hopefully it helps, and I'll see you soon.